Welcome to this explainer. Today, we are moving fast and diving straight into the completely wild physics of our oceans to uncover exactly where the absolute coldest liquid water on Earth is hiding out. You might think you already know the answer, right? But cold doesn't really mean what you think it means when you're dealing with water that is literally fighting to freeze. The real answer? It's hidden in places most of us don't even know exist. So let's jump right in. Let's kick things off with a classic geographic rivalry. If you had to guess right now, which polar ocean is actually colder? Is it the Arctic Ocean way up at the top of the world, or the Southern Ocean surrounding Antarctica down at the bottom? It seems like a super simple question, but as you'll see as we zip through the data today, the answer depends entirely on exactly when and where you happen to be measuring. To figure this out, we've got to look at their geography. And honestly, they are perfect opposites. The Arctic is essentially a giant ocean totally trapped by land masses. Think North America, Europe, Asia. Water can really only squeeze in and out through a few narrow gateways. But the Antarctic? It's the complete reverse. It's a massive, frozen continent completely surrounded by a relentless, free-flowing ocean. No land barriers to stop it, which creates this absolutely massive, unstoppable current. And this just brilliantly highlights the sheer frozen scale of the South. Look at this. Antarctica alone holds a staggering 90% of all the ice on our entire planet. 90%. Because it's this massive, high-altitude continent, sitting way up at an average of over 2,000 meters above sea level, it creates an environment that is just so much more extreme than the flat sea ice you find up in the Arctic. Now, because of that intense geography, the air temperatures are absolutely punishing. We're talking winter air temperatures at the South Pole routinely plummeting to an average of minus 60 degrees Celsius. That's a brutal, mind-numbing kind of extreme that honestly should just flash freeze everything in sight. And yet, the ocean surrounding this completely frozen wasteland, it's still churning with liquid water and marine life. So the million-dollar question is this. With the winter air being that insanely cold, how on earth does the Southern Ocean remain liquid at all? I mean, we all know freshwater hits its freezing limit right at 0 degrees, right? But this massive ocean at the bottom of our world just completely defies that simple physical boundary. Let's look at why. The secret actually lies in the unique chemistry of salt water. Basically, the more salt you have dissolved in the water, the lower its freezing point becomes. So while your everyday freshwater freezes at 0 and the slightly salty Black Sea freezes at -1, the open ocean is packed with salt and doesn't freeze until it hits minus 1.8 degrees Celsius. The salt literally acts like a physical barrier, running interference against the water molecules that are desperately trying to link up and form ice crystals. And because of that specific salinity rule, surface waters at both poles during the winter hit a hard physical ceiling at exactly minus 1.8 degrees Celsius. At this exact temperature, the ocean stops cooling down and instead just starts churning out ice. So if we're only looking at the surface during the dead of winter, the Arctic and the Southern Ocean are in a dead tie. They both sit at exactly minus 1.8 degrees. But hey, here is where the real twist comes in, the summer contrast. When that 24-hour summer sunlight finally arrives, it rapidly warms up those shallow, landlocked Arctic margins to somewhere between 5 and 7 degrees Celsius. Meanwhile, the isolated Southern Ocean, constantly buffered by that massive circumpolar current we talked about, stays frigid all year round, hovering barely above freezing. So when summer rolls around, the Southern Ocean definitely takes the crown. But if we want to find water even colder than the surface, we have to dig deeper. We've got to look at these extreme coastal ice factories in Antarctica called polynyas, and a fascinating physical process known as brine rejection. You see, when seawater freezes, those forming ice crystals are actually pure fresh water. All the salt, it gets violently pushed out or rejected into the surrounding liquid. Just imagine those frigid, howling winds blowing off the Antarctic continent and literally flash freezing the surface water. As that ice rapidly forms, it aggressively spits out the salt. The liquid water that's left behind becomes incredibly salty, heavy, and dense, and it just plummets straight down to the ocean floor like a rock. This exact chain reaction is the beating heart of Earth's heavy salt engine. This continuous, unstoppable, heavy salt engine churns out millions of cubic meters of what scientists call Antarctic bottom water. It sinks all the way to the seafloor, and then spreads that extreme cold all over the globe, flowing northward right along the bottom of the Atlantic, Pacific, and Indian Oceans. It's essentially this massive invisible river of hyper-chilled water that helps regulate our entire planet's climate. Now get ready for this, because the absolute coldest liquid water on Earth isn't actually out in the open ocean at all. Nope, it's trapped in pitch-black cavities deep beneath Antarctica's massive floating ice shelves. We're talking about platforms of ice that are hundreds of meters thick, extending straight off the continent and out over the water. And down in those dark, tightly squeezed cavities, the normal rules of physics just change completely. Down in those hidden depths, we basically have a perfect storm for extreme cold. You've got the enclosed, isolated space of the subglacial cavities. You have insanely high salinity from all that constant brine rejection. But most importantly, you have the crushing weight and pressure of literally kilometers of ice pressing down from above. That immense pressure depresses the freezing point even further, allowing water to stay liquid at temperatures that just seem impossible. As you can imagine, exploring these pitch-black freezing cavities is incredibly dangerous. So scientists send in advanced autonomous underwater vehicles. And when these high-tech robotic subs navigated deep beneath the ice shelves, their sensors picked up something incredible. Seawater sloshing around, still in liquid form, at a chilling minus 2.2 degrees Celsius. That is so much colder than open ocean surface water can ever possibly reach. But hold on, because the official Guinness World Record takes things even further. Back in May of 2010, a team of Norwegian scientists logged an absolutely astonishing minus 2.6 degrees Celsius under an Antarctic glacier. Minus 2.6, because of that intense pressure and ultra-high salt content collecting in little hollows right on the seabed. This water simply refuses to turn into solid ice. Water in this state is known as being super-cooled. It is hovering so incredibly close to the brink of freezing that even the tiniest sudden disturbance can trigger a genuinely terrifying phenomenon. In the Weddell Sea, which is widely considered the cleanest and coldest sea on Earth, they occasionally see actual flash freezes. These supercooled liquid waves can turn into solid ice instantly, right before your eyes, trapping any unlucky ships in a deadly, icy grip. Now, if you think minus 2.6 degrees is extreme, just wait until we pull back the curtain on the geological record. What happens when we rewind the clock, say 700 million years, to a terrifying era known as Snowball Earth? This was a period when massive glaciers stretched all the way from the poles right down to the equator. A super fascinating recent analysis by scientists looked at ancient iron isotopes left behind in rusty rock formations. Since these iron isotopes actually change their composition based on temperature, they basically act like a prehistoric thermometer. And the results? Totally staggering. They revealed that prehistoric ocean margins reached a mind-numbing minus 22 degrees Celsius without actually freezing solid. Let that sink in for a second. I know what you're thinking. How on earth did an ocean stay liquid at minus 22 degrees? Well, because the oceans back then were a hypersaline soup. As those massive glaciers formed and squeezed out salt, the ocean salinity skyrocketed to 150 practical salinity units. That is more than 4 times saltier than our modern oceans. This massive, dense concentration of salt acted like a super-powered natural antifreeze, which actually allowed early microorganisms to survive the deep freeze. Bringing things rapidly back to the present day, we are facing a starkly different reality. Our modern heavy salt engine, that massive, invisible system distributing dense, cold water around the globe, is under severe threat. Recent studies show a really disturbing trend. Even the deepest, darkest, and most completely isolated abysses of the ocean are steadily starting to warm up. And this warming kicks off a highly dangerous chain reaction. Shrinking sea ice means less sunlight is reflected back into space and more heat is absorbed by the water. That melts more fresh water from glaciers, which then dilutes the ocean's saltiness. With less salt, the water just doesn't get heavy enough to sink, which threatens to literally jam the global salt engine. Plus, this warming destabilizes the stratospheric polar vortex, sending chaotic, extreme winter freezes spilling right over into North America and Eurasia. So, as we wrap up this fast-paced explainer today, I want to leave you with this final thought. We've seen how this incredible, delicate balance of salt, temperature, and pressure manages to hide liquid water at totally impossible temperatures. But as the ice vanishes and our oceans become fresher, what will happen to the global climate when Earth's heavy salt engine finally grinds to a halt? It's a massive mystery, and unfortunately, we are the ones currently writing the ending.